Alright, today what we are working on is graphing systems of equations. And again, we are discussing graphing systems of equations, which is very simple. All it is more than one equation on one graph. A system means you have more than one. And of course, I told you earlier that there's other systems with 3 lines and such, but right now we're only going to focus on solving a system of equations using graphing. Now, our solution, something that we need to keep in mind, that our answer is a point. And so we need to continue to remember that we're looking for a point if we can find it, or a reason why there is no point as an answer. So you're not finished until you have a point or a reason that there isn't a point. And I'll show you that here in a second. There are several ways to graph or solve a system of equations. And we're going to use graphing, but there's also substitution and elimination. But with all that jibber jabber talk, let's actually get right into it. How do we actually find it? The first thing you want to do is graph your lines. And so you need to know slope-intercept form. You need to know how to graph a line. And then we want to see where the points intersect. And in order to get a really good picture of the line, you want to probably use more than 2 points. So 3 or 4 kind of gives you a good idea, and you want to use a straight edge. So let's jump straight into it. Let's look at number 2. Says graph the lines and find the solution. First of all, we see that each equation is in slope-intercept form, so we can actually graph those. And so that's what I'm going to do. I'm going to graph those 2 equations. And so let's do that. Y equals negative x plus 5. So y equals negative x plus 5 is 1, 2, 3, 4, 5 right here. And negative x is down 1 to the right 1. But I want more than just 2 points, and so I'm going to do it again. Down 1 to the right 1, and so on. I can keep going so I can get a really good looking line. And then I draw a line through all those points. That's my first line. My second line is y equals 3x plus 1. 3x plus 1 is plus 1 right here, or 1. 3x is the slope up 1, 2, 3 over 1. Up 1, 2, 3 over 1. So I have a good picture of what my line looks like. So I draw, and you can see that those 2 lines intersect at this point right here. So when you graph, you don't stop right here. What you do is actually finally write what your answer is. My answer is over to the right 1 and up 1, 2, 3, 4. So that is the point of intersection for those 2 lines there. Alright, let's look at our next example. They want us to find a solution, and we want to do it by graphing. Again, we can't graph this the way it looks. So these 2 equations don't look like this one. So I'm going to put them in slope-intercept form. So I get y equals negative 3x plus 4. And then over here, with x minus 2y equals 6, I'm going to subtract x. And divide everything by negative 2. That's the same thing as x over 2 right there. So now I'm going to take both of those. So sometimes you can graph the way they look, and other times you're going to have to put them in the proper form. So let's graph that. Y equals negative 3x plus 4. So I'm going to graph that. Plus 4 is 1, 2, 3, 4. Negative 3x is down 1, 2, 3 to the right 1. Down 1, 2, 3 to the right 1. And so that's how you would actually put those points on the graph. Alright, so I had 3 points. I just want to show you something. My slope was negative 3. And if I start back here and I go up 1, 2, 3, and then go negative 1, notice that I'm still in tune. I can put my negative in the numerator or the denominator, but you can't do both because that means positive. And gives me the opportunity. On some of the assignments, you'll find out that you need to go the other way, and so you need to put the negative in the numerator or the denominator, whichever one will fit on the graph. The next equation is y equals 1/2 x minus 3. So again, I'm going to do minus 3 first. 1, 2, 3. And 1/2 is up 1 to the right 2. Wait, up 1 to the right 2. Up 1 to the right 2. And I don't really need to do 2 since I see where the point of intersection was. I just want to show it to you. So solving systems of equations by graphing, again, is asking us to find the point where two lines intersect. The graph is not your answer. The answer is the point where they intersect. So if I go to the right 2, and then I go down -2, that is your point of intersection. Now, real quick, you can check your work. We found out that the answer to 2 was, for this problem, because they're both called 2, the answer is 2, -2. And so what has to happen is, if they ever give you a point, all you have to do is take the x and the y and substitute them into both of your equations to see if you get a true statement. So for example, -2 equals -3 times 2 plus 4. What did I do? I substituted y and x into this equation. Now I could have went to the original as well. It doesn't matter. Let's see if this is going to equal -2. -3 times 2 is -6 plus 4. Does -6 plus 4 equal -2? Yes, it does. But it has to work for both. It can't just work for one. Keep that in mind because it'll come up sometimes. When you check a point, it has to work for both equations. So let's try it over here. If I put -2 in for y, 1/2 times 2 minus 3, I just put that in for x and y, I get -2 equals 1/2 times 2 is 1. Let me ask you, 1 minus 3, does that equal -2? Yes, it does. So that point works for both. Sometimes they will give you a point and they'll say, is this point a solution? And the way you check that, you don't have to graph. All you have to do is substitute it into both equations to see if you get a true statement. If one of them is off, then it's not a solution. It has to work for both equations. All right.